In this lecture, I'll be talking about why you should use Spinnaker. Why Spinnaker? The Spinnaker goal is to make reliable deployments. Spinnaker offers deployment pipelines and also allows for easy rollbacks. It's built for high velocity, so deploy fast and often. This is very important to organizations to be able to release features quite fast to your customer base. It has a flexible pipeline management system, and it has a very big active community. It integrates with all the major cloud providers and Kubernetes, like Amazon Web Services, Microsoft Azure, Kubernetes, Google Cloud Platform, and OpenStack. It's very feature-rich, so it has CI integrations with Jenkins, CircleCI, whatever more. It has a command line interface for setup and administration. It has a VM bakery. It can build Amazon machine images, Google Cloud images, Docker images, and other cloud-specific images. It has role-based access control. It has a whitelisted execution window. So you can say, for example, you can only deploy between 1 a.m. and 2 a.m. in the morning. So it has monitoring integrations. So, for example, you can be alerted when a deployment fails or just disable the monitoring in a certain time period when the release is happening. You have a lot of deployment strategies. You can set up notifications, so let's say you want to deploy a successful post a message in Slack, and you have manual judgments. This is a step in the deployment pipeline, where you send an amount of traffic to the component to see how well it reacts in the whole environment. And you got Chaos Monkey, but more about that in our advanced lectures. Another important reason to use Spinnaker is because the Kubernetes Deployments API is not as advanced as Spinnaker. Spinnaker completes Kubernetes by using powerful deployment pipelines, allowing for multiple deployment strategies. Kubernetes support in Spinnaker is feature complete, and you have direct access to the Spinnaker API without being forced to use the UI if you don't want to. The documentation is fully available, so that's pretty important for a project like this. Deployments are built in and no custom scripting is needed. I will show you in the next diagram. So we're going to read this diagram from left to right. The first step is the code check-in, so a developer pushes the code. Then the continuous integration will perform some tests and delivers an artifact. And then Spinnaker takes over. In a lot of organizations, this Spinnaker pipeline is a lot of custom scripts. So with Spinnaker, there's no need to keep those custom scripts, as it can take over from baking to live code. In between bake and live, you got the deployment. You got a prod deploy, for example, plus a test. You can do hotfixes. You can have a canary, where you send an amount of traffic to a certain node to see how it reacts. So in other words, it's one solution to replace a lot of custom unpredictable scripts and tools. Here you can see an example from a deployment pipeline at Google Waze. So you see the code commit and a Jenkins build. After that, Spinnaker takes over and it bakes an AMI in AWS and a Google Cloud image in Google Cloud. Then it runs some integration tests on that machine. Then it deploys it to staging. Then it goes to production, to the canary to see how it responds in AWS as well as in Google Cloud. Then there's a canary analysis. This canary analysis can be manual judgment or an automated step where if it doesn't return error codes or whatever more, it goes on to the next deployment strategy, in this case the blue-green deployment. Then it's going to deploy it to production AWS and at the same time it's going to deploy it to Google Cloud. Then there's an optional rollback. Let's say the feature throws out a bug or something customer related. But in a normal flow, the next step is to destroy the previous groups, Google Cloud and AWS resources, because everything is immutable at Google Waze. I hope this gave a better understanding why you should use Spinnaker. Hope to see you in the next lecture. Bye.